Hello, Algebra 1. Guys, I have not seen you, it feels like, in forever. I miss you all so much. I hope you're all staying busy and healthy. You're getting outside and doing some fun stuff, riding a bike, skateboarding, going for a walk, and that you're all doing really, really well at home. What I've decided to do is jump on to YouTube and shoot you guys a video. I'm going to go page by page, so hopefully these are fairly short. I get talking, and then you guys know I get all distracted. So today what I'm going to do is I'm going to go over the first page of your Unit 3 review, okay? So you can watch these, and hopefully I do a good job explaining, and then if you have any questions, just shoot me an email. If you want to do a face-to-face, you can let me know, and we'll do like a FaceTime or something like that, okay? So anyway, here we go. Number 1, the expression x to the 4th minus 16 is equivalent to. So what you have to know is that you have to take this binomial and you have to factor it, okay? So there is no GCF, remember Schneider on your shoulder. So then I say, how many terms are there? 2, and it has a subtraction sign here. So with 2 terms, remember we break it into 2 parentheses. We break up x to the 4th as x squared times x squared. We break up 16, careful, as 4 times 4. And with difference of squares, one is always positive and one is always negative. And that answer is right here, number 3. Now, I don't super duper love this one because I think you guys should recognize that this factor is difference of squares as well. So if you factored this completely, this guy does not change. And the reason it doesn't is because of the plus sign. And then this also fits difference of squares. So you'd break up x squared into x times x. 4 is 2 times 2. 1 positive, 1 negative. So there's just a little review for you, okay? But the correct answer is number 3. Taking a look at number 2, an expression of the 5th degree, that's important, that is vocabulary, is written with a leading coefficient of 7 and a constant of 6. So here is the deal, guys. If you take a look at these, they are all written in standard form because they go from the highest exponent down to whole number, highest exponent down, highest exponent down. The 5th degree. Remember if I said it's like, oh, it's 40 degrees outside. Remember how we put a degree up here? The degree is going to be your exponent. It's the highest exponent. So 5th degree. Well, this one has a 5th degree. It is the highest exponent. This one is not. That's a 6th degree. This one is not. This one is. So you're down to a 50-50 shot of guessing. It's either 1 or 4. Aiden, you'd be surprised because number 1 is usually a distractor, right, buddy? Okay, leading coefficient. If you are leading the race, you are out in front. So I'm telling you the number in the front is 7. Oh, not you, buddy. So the correct answer is number 4. The constant is the whole number. It has no variable attached to it. So there is number 2. Number 3, we're going with a system of equations. A celluloid cinema, oh, that's a tongue twister. Celluloid Cinema sold 150 tickets to a movie. Some of these were children's, the rest were adults. A child's ticket cost $7.75, an adult ticket cost $10.25. So what we would do is we would tie $7.75 with a child. So $7.75 for every child. Adult tickets are $10.25. So $10.25 for adults. And I always tell you, what do we do with these two numbers? Always, always, always. You add them. So $7.75 is money. $10.25 is money. So the only other number here that is money is this one. So it's going to equal $14.70. Now, the second equation you have to write is a little bit trickier, but it's actually super duper easy. But as a good test taker, you might want to go and look and see which one has 775C plus 1025A. 775C, 1025A, that's good. 775C, 1025, that's good, darn it. Oh ho, these ones don't have the right things attached. 3 is gone, 4 is gone. Okay, they did adult tickets were $7.75. No, they're not. So here we go. The second equation, all we're going to do is we're going to remove the money. So if the money goes away, you have C. If you remove the money, you have A. I have to remove this money. Well, I can't have nothing floating over here. So if you look over here, the only other number in this whole question is 150. So then you find it. Oh, there you go. Welcome to the Schneider house. Someone drove by and Bailey and Macy are not having any of it. All right, last one for today. The table gives values of 4 different functions. Now notice they're named different. This is function f, function g, function h, and function k. That tells me they're all different because they all have different numbers. Which table represents a linear function? So we know lines, right? Lines can go in many, many directions, but they're straight. And the reason why they're straight is because they are either growing or shrinking, they could go this way, at a constant rate. A constant rate. So what we're going to do is we're going to look and see how this one's growing. So from 12